Motional e.m.f. Topic: derive. Means when there is motion, then what is e.m.f? Derive expression for induced e.m.f. When a conductor of zero resistance PQRS is bent twice at right angles and placed perpendicular to uniform magnetic field. Another conductor AB is free to move on PQRS. Then hence find current and its direction, force on conductor AB, power on conductor AB, motion of conductor as shown. This is PQRS conductor. This is another conductor AB. It is placed in uniform magnetic field and motion of conductor is this. Again question. Derive an expression induced e.m.f. when a conductor of zero resistance PQRS is bent twice at right angle. ये PQRS है conductor. ये bent है twice at right angle. Q and R. It is bent here and placed perpendicular. ये cross जो है field है इसमें perpendicular. यानी ये समझिए ये PQRS conductor है और B कहाँ है अंदर. ये this conductor AB is moved as shown. It is free to move. It is moved as shown. To derive expression for induced e.m.f, current, direction, force on this conductor, let L AB length R small r resistance of AB. ये जीरो भी हो सकता है रेजिस्टेंस, इसका रेजिस्टेंस आर हो उसका है V velocity of conductor first induced e.m.f. If there is change in flux, then e.m.f. Then phi be a cos theta, phi be a cos 0, ये एरिया है, ये बोर्ड एरिया है, ये नॉर्मल है, इधर ही बी है, थीटा इज 0, इट इज बी ए. As conductor moves, area changes. So, magnetic flux changes. Hence, induced e.m.f. ये कांस्टेंट है, ये बदल रहा है, तो इट विल चेंज. Hence induced e.m.f. by Faraday first law of EMI. What first law states? If there is change in flux, there will be what? Induced e.m.f. No change, no e.m.f. Here flux is changes, so e.m.f. And that e.m.f. that is in magnitude, it is what? d phi by dt or e d phi by dt. One wire है, one number of turns, one. From where? Faraday second law of EMI. dt phi BA, B outside, dA by dt, B d area. Suppose conductor is here. ये डिस्टेंस है, तो एरिया विल बी L into x. L constant, length of conductor, dx by dt, or it is dl dx by dt is b e minus blv. Why minus? Lenz's law. Again question. PQRS, conductor bent twice at right angle. This is another conductor, it is free to move. R is resistance, total resistance. If it's 0, then this resistance is small r. If it is 0, then this resistance will be what? Small r, say. This conductor is free to move. It is placed where perpendicular to magnetic field. Find induced EMF. तो क्या करोगे पहले? फ्लक्स देखोगे चेंज हो रहा है या नहीं. चेंज हो रहा है, area changes, so flux changes. So what? EMF, Faraday first law. And how much that EMF? It is minus BLV. Then what? Current and its direction, force. These things. Current, that is I. E by R. What is E? Minus BLV by R. Direction. ये कंडक्टर था, ऐसे मूव किया था हमने, ऐसे फिगर, ये ऐसे. When there is induced EMF, then we apply this rule. This rule. Fleming's right hand rule. This is current. This is B. Look, this was B. This was force. So direction of current is from A to B. Fleming's right hand rule. When we apply EMF to a particular, then this rule. When there is induced EMF, this rule. Look again. ये कंडक्टर था हमारा ए बी. मार्कर इज कंडक्टर, बोर्ड पे ये मूव करा था हमने. कहा? लेफ्ट में. फिगर देखो, फिगर लेफ्ट में. तो ये लगा दिया. ये अंगूठा फोर्स, डायरेक्शन ऑफ मोशन, ये बी था अंदर, तो नीचे फ्रॉम ए टू बी. तो डायरेक्शन क्या होगी? द डायरेक्शन इज ए टू बी, और क्लॉकवाइज डायरेक्शन कह सकते हो. फोर्स, force on conductor F, I, L, B, sin theta. Theta is angle between L and B. ये L है, मार्कर L था बोर्ड पर. ये भी ऐसे मूव किया था, और B अंदर, तो इट इज ILB sin 90. तो फोर्स विल बी ILB. And what is I? BLV by R LB to force P square L square V by R. This is force. Power on conductor, power EI, E minus BLV, I minus BLV by R. It is plus B square L square V square by R. Power Ri square, Ri square, this is I, minus square, so plus B square L square V square by R square, again it is B square L square V square by R. So this is what e.m.f, current, force on conductor which is moving perpendicular to magnetic field. Derive expression for induced e.m.f when a conductor one end hinged is rotated in uniform perpendicular to uniform magnetic field. This is the question. This is uniform magnetic field acting inward. This is a conductor. This end is hinged. The conductor is rotated. Theta is angular displacement. B uniform magnetic field AB L length of conductor theta angular displacement derive expression for induced EMF. When there will be induced EMF if there is change in flux. Now magnetic flux that is phi, it is BA cos theta. अल्फा ले लो यहाँ क्योंकि थीटा तो ये एंगल लिया हमने. Where what is alpha? The angle between B and normal to area. ये बोर्ड पर ये B है और ये जो एरिया बन रहा है इस पर नॉर्मल करोगे तो उधर 0, तो फाई इज BA. As conductor moves, B constant, area A changes. ये बदल गया, ये कांस्टेंट है तो फाई चेंज हो जाएगा. सो मैग्नेटिक फ्लक्स changes, hence induced EMF, that is why Faraday first law of electromagnetic induction. फ्लक्स चेंज हो रहा है EMF and that E d phi by dt why Faraday second law of EMI d dt BA B constant dA by dt now dA if angle is 2 pi then area is pi L square. L was length. Okay, 2 pi total angle to total area. If angle is 1, the area is pi L square by 2 pi. Pi goes with this pi. If angle is theta, L square to theta. This is DA. क्या है ये? एरिया. पूरा एंगल 2 पाई बनता तो एरिया ये 1 है तो दिस एंगल थीटा बनाया. दिस इज दैट एरिया. ये दिस DA. It is B ddt. What is it, that area now? L square theta by 2. Constant outside B L square 2. D theta by dt. Or it is B L square omega by 2. this is what induced EMF d theta by dt, angular velocity, and E minus BL square omega by 2 Y minus Lenz's law. Derive an expression for induced EMF when a coil is rotated in uniform magnetic field or magnetic field is rotated around a stationary coil. Hence find current. This is a question. Derive expression for induced EMF when a coil is rotated in uniform magnetic field. This is a magnet, another magnet. This is coil. This is B. Either coil is rotated or coil is stationary, magnetic field is rotated. Both cases. B, uniform magnetic field. E, area of coil ux yz. Omega, relative angular velocity of coil. Derive expression for induced EMF. When there will be induced EMF if there is change in magnetic flux. Now magnetic flux. Phi, it is BA cos theta. This is constant, this is constant. As coil rotates, theta changes. अब 90 एंगल है, ये बी की डायरेक्शन है, ये एरिया पर नॉर्मल है, 90 है, अब ये थीटा. तो when coil rotates, the theta decreases, changes. As coil rotates, theta changes. So phi changes. Hence what induced EMF by Faraday's first law, electromagnetic induction, and that EMF d phi by dt. Faraday second law. EMI d dt BA cos theta BA d dt cos theta BA d dt cos omega t is what? Theta by t minus BA cos omega t minus omega sin omega t, and BA omega sin omega t, n number of turns E and BA omega sin omega t, or E naught sin omega t. So this is y minus plus here, Lenge's law. What is E naught? It is NBA omega. And what is I? E naught by R sin omega t, or it is I naught sin omega t. So this is expression for induced EMF when there is relative velocity between magnetic field and coil. When coil rotates, a magnet falls through a conducting loop its acceleration is equal to acceleration due to gravity. loop is having cut, then is acceleration of magnet equal to G. ये कंडक्टिंग लूप है, ये मैग्नेट है, मैग्नेट ये फॉल हो रहा है, देन इट्स एक्सील फ्री फॉल मारकर छोड़ दिया, क्या एक्सेलरेशन होगा इसका सी। अब ये छोड़ दिया ऐसे, when magnet falls, मैग्नेटिक फील्ड लाइंस क्या होती जाएंगी, इंक्रीज। सो मैग्नेटिक फ्लक्स linked with the loop changes, hence induced e.m.f or current in loop in such a direction to oppose fall of magnet. Why? Lenz's law. So, acceleration of magnet will not equal to G. Now second part, if loop is having cut, if loop is having cut, then there is induced e.m.f. but no current. So Lenz's law not applicable. So acceleration of magnet is equal to